Yep. Hello and welcome to Soft Papers channel. I'm Godfrey. In this video, I'll be solving chemistry topical question on chemical energetics. This is October-November exam series of 2019 S level. I encourage you to do your revision as you prepare for your exams topic-wise. Read your notes and your textbook on a given topic, and when the content is fresh, then attempt topical questions on several years, 2019, 2018, going backwards. This way you will get to learn the key areas that the examiners are fond of testing, and you will be you learn how to answer the questions topic wise, and that is a sure way of getting your A star. So try that if you have not yet already started. Doing past papers, full past papers is quite okay, but before you get to that, topical question is the way to go. Let's proceed. And if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will always be notified every time I upload a new video. If you find these videos useful, please share them. Share with your friends. They also get to benefit. That out of the way, I would like us to get started. In all my videos, every question is indicated which paper it was obtained from. 9707, that's the code for chemistry S. We have variant 1, 1, 1, 2, 1, 2, 1, 3. This is variant 1, 1, October, November 2019, and this was question number 7 on paper 1, 1. So from this, each question, you can be able to know which paper it was set from, if you need to refer, and also to check up with your marking scheme. Question number 1. The following data are needed for this question. You need this one for this question. Of course, this is the enthalpy of formation of hydrazine, and the enthalpy of formation of dinitrogen tetroxide, and enthalpy of formation of water. You are told hydrazine reacts with dinitrogen tetroxide to form nitrogen gas and water. Form nitrogen gas and water. The equation is given right here, and the question here is what is the enthalpy formation for this reaction? Okay, if I may rewrite this reaction again here. So you use SS law to get this question worked out. Plus nitrogen tetroxide. Of course, this will be the enthalpy of reaction. That is what you're supposed to. The enthalpy change in this case will be enthalpy of reaction, and here you get nitrogen and water, 3 moles of nitrogen and 4 moles of water. Of course, the elements from which all these compounds are obtained from, you can see we have 4 nitrogen atoms there and 2, so that's 6. So we have 6 nitrogen plus how many? This is 8 plus 8 hydrogen plus 4 oxygen. Okay, so you can get to hydrazine when 4 nitrogen atoms combine with 4 atoms of 8 atoms of hydrogen, and this will be enthalpy change of formation of hydrazine. Of course, there are 2 moles there. You include the 2 moles there. You can get to dinitrogen tetroxide, which is 1 mole. So you'll have the enthalpy of formation of nitrogen there, and dinitrogen tetroxide there. Can also get to the water, which will be 4 times the enthalpy of formation of water. Enthalpy of formation of water. Of course, the enthalpy of formation of any compound that is made of the same atoms is basically 0. So you just ignore the nitrogen right there. So according toEnz's law, you can see you can move in that direction. Okay, when you move this direction, you'll be able to get here. Okay, so here then you'll have these two enthalpy of formation of hydrazine plus the enthalpy of formation of dinitrogen tetroxide plus the enthalpy change of reaction, which is this one. This would be equal to the 4 enthalpy of formation of water. Which is this? So what is the enthalpy of formation of hydrazine? We are given that here. So it is going to be 2 times 50.6 plus enthalpy of formation of dinitrogen tetroxide is 9.2 kilojoules right there, plus enthalpy of change of reaction, which you're supposed to be finding, which goes to enthalpy of formation of water, which is enthalpy of formation of water is minus 241.8. So of course, when you make the enthalpy formation of course of the enthalpy change of reaction, then of course you will multiply these, add these, and then minus both sides. And what you're going to be getting here is when you multiply these, you'll get 967.2. Of course, when you add these and this, when you multiply this by 2 and add to that, you'll get 110 positive. Then of course, when you minus it both sides, and what you're going to be getting here is this minus and minus, you get minus 1077.6, and this is kilojoules per mole. Look at this, and you find that the answer is right here. Very well. Question number 2. Question number 2 was from variant 1.1. This was question number 8. We are told sodium burns in oxygen, giving out heat energy and forming compound this sodium oxide. The equation for this reaction is shown. Which statement about the reaction is correct? The change in energy for the reaction is equal to twice the bond energy of sodium oxygen bond. Which statement about the reaction is correct, right? The bond energy there cannot be equal to that, so I'll go for the others. That is not right. B, the change energy change for the reaction is positive. This is burning. Sodium burns in oxygen. So if it is burning, it means that it is exothermic, and therefore it is negative, not positive. Therefore, this is not correct. The equation represents the standard enthalpy change of combustion of sodium. If it is standard enthalpy change of combustion of sodium, then we should be having 1 mole of oxygen. 1 mole of sodium. But as you can see here, we have 2 moles of sodium. Therefore, this is not standard, right? That makes that part there not correct. The equation represents the standard enthalpy change of formation of sodium oxide. And you can see sodium oxide here is only 1 mole, and therefore that is correct. Standard enthalpy change of formation of sodium oxide. The right answer there is D. Okay. Before we go to number 3, it's great that you're watching this video, but remember, practice makes perfect. I encourage you to practice working out these questions yourself as I guide you. So you may get this same paper I'm solving right now, from this site right here, softpapers.co.uk. I may show you the site right here. This is the site I'm referring to, softpapers.co.uk. This is a very resourceful site. You can visit it and get the papers right here. This is a 2019 AS topicals. You can click this one, and of course it will bring you right here. You can get 2019 topicals here. Of course, you can also get 2019, 2018, all these years I've got topicals and also past papers, as you can see right there. Right now we are solving chemical energetics, this paper here. You can click and get that. Of course, I encourage you to get all these topicals, both November and June. They're all there available for you. So what you need to do is just click this green button here, and of course you'll get to this page whereby you can you find all the papers right there. We'll have both solved and unsolved, and you can do good to of course request your parents to make this, to help you with this one. Papers are only costing around £10, not much, for an investment to be sure you'll get your A star. So you get these papers, and then once you have the papers, then you can come and we continue in this video. Hopefully that will be of help to you. Let's continue with question number 3. Which reaction is endothermic? Which reaction is endothermic? Now let's look at the first reaction here. Endothermic is a reaction that absorbs energy from the atmosphere or from the surrounding. This is a base, and this is an acid. So basically this is a neutralization reaction. A neutralization reaction. And as we know, all neutralization reactions are exothermic. Neutralization reactions are exothermic. So this is not endothermic. Now look at part B. This is 2 atoms of chlorine in gaseous state to give us a molecule of chlorine. So this is the formation of chlorine, and formation of chlorine involves making new bonds, and new bonds formation of bonds releases energy. So formation of chlorine molecule is exothermic. Formation of bonds releases energy. So that is not correct. What about this other question here? We are looking for the one which is endothermic. This is 2 calcium atoms in solid state reacting with oxygen, and therefore this is basically burning calcium metal in oxygen, and all burning is exothermic. So calcium burning in oxygen, and is exothermic. So it is not endothermic. So basically the right answer here is D, but let's see why that it is the case. Calcium carbonate undergoes thermal decomposition to get calcium oxide and oxygen. So thermal decomposition requires energy from the environment, right? So it requires input of energy from the environment, and therefore this is endothermic. Of course, as I've said, this is a thermal decomposition. This is thermal decomposition. Thermal decomposition of calcium carbonate, right? And requires energy input. So it is endothermic. So that's why this is correct. Very good. Number four. Which equation correctly represents the standard enthalpy change of atomization of a given element? Right? Standard enthalpy change of atomization. Now, look at the first example, first choice, that is part A. Part A, we are finding that an iodine molecule in gaseous state is being converted to a iodine atom. Okay, and this is basically both vaporization and atomization. We are looking for atomization of the element. So this is both vaporization, right? Vaporization and atomization. All right, so that is not correct. What about B? You find that sodium atom in solid state is being converted into sodium in gaseous state. And I think this should be correct. This should be atomization. Look at that standard enthalpy change. So standard is 1 mole of sodium in solid state is being converted to 1 mole of sodium in gaseous state. And I think this is atomization. And it is standard because it is 1 mole of that. Okay. Why is C not correct? We are having 2 moles here of chlorine formed. Therefore, that is not standard enthalpy. Although it is atomization, but that is not standard enthalpy. And of course, it is basically still vaporization and atomization. Why is here we have 2 moles of chlorine atoms, so not standard. Standard, the number of moles should be only 1 mole. What about this one? This one is of course from 1 mole of sodium in gaseous state to 1 mole of sodium in ion in. So this is sodium in gaseous state, and this is an ion of sodium. So this is basically what we call first ionization energy. First ionization energy. So it is not basically atomization because already sodium is in gaseous state. So the iodine, this one here, is the standard the standard condition of iodine is the standard condition of iodine. Let me put this way. Standard condition is solid, not gaseous here, right? So that is not basically atomization. Atomization, you start from the standard state of the solid. So iodine is usually in solid state at room temperature. So iodine gas is obtained by first melting, then vaporize it. To get iodine gas, you first melt and then vaporize. Therefore, this is both vaporization and basically atomization. So the right answer here is B. Number 5. The reaction pathway diagram for a reversible reaction is shown. Okay, we have energy there, progress of reaction. The reactants have got lower energy compared to the products. So basically this is an endothermic reaction. Which statements are correct? Which statements are correct? The enthalpy change for the backward reaction is 20. Of course, to get from the products, these are products here, and these are the reactants. To get from the products to the reactants, of course, you can see to get from the reactants to the products, this is plus 20, right, going this way. And therefore, to go the opposite direction, then that will also be 20, but minus. Okay, to get from products to reactants, an energy equivalent to minus 20 will be given out per mole. So this is correct. The forward reaction is endothermic. This is of course correct because you can see the products at a higher energy compared to reactants. So this is plus 20 going to the products. So this is endothermic, it's correct. The activation energy for the forward reaction is 70. Okay, you can see the activation energy is plus 70, or the forward reaction is plus 7. Activation energy is the energy between the reactants and the products, and you can see it is 20 plus 70, 20 plus 50, which is correct right there. Therefore, the right answer is all of this, which happens to be in A. So guys, that's those are the kind of questions that were the topical questions that were set on November series 2019. You realize that the questions just 5 on this topic, chemical energetics, for both paper 1, paper 2, paper 3. Paper 1-3 is the same as either paper 1-1 or paper 1-2. Therefore, these are the kind of questions helpful to do topical. You will always get a good exposure for the kind of questions that you are going to be getting in your forthcoming exam. So I hope this was being helpful to you guys. Hopefully I'll see you in my next video. Cheers and bye.